Okay, hello everybody. Good evening, all of you guys. I hope that I am audible to you. And एक बार मैं भी चेक कर लेता हूँ कि मेरी आवाज़ आप तक प्रॉपर पहुँच रही है. And if the voice is proper, then we will start our lecture, right? Okay, hello everybody. Good evening, all of you guys. I hope that I am audible to you. Okay, I think voice is clear, guys, right? And but still, if you are facing any difficulty, let me know. Let me know. So due to the bad weather, as you know that कि अभी थोड़ा सा हरियाणा पंजाब है ना, काफी हिस्सों में वेदर जो है वो बहुत ही एक परेशान कर देने वाली चीज है. और काफी चीजें जो हैं वो डिस्टर्ब्ड वे में चल रही है, तो आज यहाँ पे वेदर थोड़ा सा बेकार था. दैट्स वाई वी पोस्टपोन्ड आवर क्लास. ओके, सो कौन कौन है मेरे साथ में एक बार बात करते हैं. सो गुड इवनिंग अगेन, शिवा, महीना, अनुष्का, रोशना, साई, किया, विष्णु. And I think we have two new students, Hemant and Darshni. So guys, are you there? Just let me know that you are there. And मुझे ये भी बताइए कि मेरी आवाज आप तक पहुंच पा रही है कि नहीं पहुंच रही है. So in the previous class we have discussed the types of fluid, right? In the previous class we have discussed, bacha, the types of the fluid, or you can say the classification of the fluids. So in the broad category, we classified the fluids in majorly two categories. One is those fluids which are follow the Newton's law of viscosity, which follows the Newton's law of viscosity, and other fluids which are don't follow. The fluids which are do not follow the law, Newton's law of viscosity. Yeah. So we have the broad category. We have the two broad categories, right? And majorly, uh, if you connect this, just tell me that is it clear to you or not. In these two type of fluid, we basically discuss the variation, or you can say we discuss the relationship between the tau and you can say the shear rate, or you can say the velocity gradient, right? Is it clear to you? Or you can say we have discussed the viscosity relation with respect to the shear rate. So in this category we have discussed the relations of between tau and you can say shear rate or mu with the shear rate. I hope that previous class is clear to you, and we have discussed, you can say, the graph as well of all the kind of liquids, or you can say fluid, right? Now we have the other two fluids are there, which is basically time dependent, So the next heading is time dependent fluid. Time dependent fluid. One second, guys. Yeah. So we have discussed the time dependent fluid, right? So time dependent fluid, so we have the two fluids which are time dependent. One is the thixotropic. One is your thixotropic. Okay, right? So thixotropic fluids are those fluids which have the variation of the apparent viscosity with respect to the time at the constant shear rate, right? So in this thixotropic, you will say that apparent viscosity basically decreases with respect to time, right? Second point, you can write that at constant shear rate, shear stress, which means tau, decreases with time to a minimum value, right? So thixotropic is basically that fluid which have the apparent viscosity decreases with respect to the time. And the second statement you have to remember that at the constant shear rate, my shear stress means tau basically decreases with the time to a minimum value. Okay, here are some examples for the thixotropic, like paint, like ketchup, like honey. These are some examples for the thixotropic. Guys, remember ये जो examples है ना, these examples are also important. So from this topic there are kind of two questions. One is the variation, whether it is maybe of the mu or with respect to time, or mu with respect to shear rate. And another question may be kind of the examples, that okay, paint is which kind of fluid is this, right? And जो different PSUs के exams होते हैं, in that exams they may ask, the probability is very high to ask the example, right? But in the gate examination they will ask the based upon the equation of the fluids, and you can say variation. So both the informations are important for us. Is it clear to you? Another is the rheopactic, which is the opposite to the first one. Rheopactic, right? So what is the rheopactic? So in the rheopactic, apparent viscosity increases with time. Increases with time, right? And second statement is at constant shear rate, at constant shear rate, shear stress is increases with time. Right? Here are some examples, like printer ink, gypsum suspension, and bontonite clay. So these are the some examples for the rheopactic, right? So if you see the variation, or you can say if you see the graph, at the x-axis it is T, at the y-axis it is mu apparent. That in the thixotropic, mu is basically decreases with time. So this kind of graph, this kind of roughly graph you will get in the case of thixotropic. And for that is mu app is basically increases with time. So this kind of graph you will get in the case of rheopactic, right? So basically the question is something based upon the variation, that which one fluid has the mu apparent increases with time. This kind of question they may ask, right? Is it clear to you guys? यस, कौन कौन है एक बार लाइव? कैन यू टेल मी कौन कौन लाइव देख रहा है जल्दी से? एक बार मैं भी चेक कर लेता हूँ कि यस एवरीबॉडी, लेट मी नो गाइस. The new students are present or not? Hemant and Darshni, guys, you have to message me uh, on the Telegram, if you are not aware about it. So that if you have any doubt, if you have any problem, then during the class you have to message on the Telegram, right? आप टेलीग्राम के ग्रुप में, FMIPC ग्रुप में आप ऐड हो चुके होंगे, आपको वहां पे बताना है. Okay, one fluid is there which we have discussed in the starting of the class. Okay, so let's take a short discussion on that also. That is viscoelastic fluid. So just remember the definition, right? Viscoelastic fluid. Viscoelastic fluid. So as the name suggested, this fluid has both the properties. This fluid has both the properties. Means visco means this fluid is viscous, and elastic means that this fluid has the elastic properties also. So we can say that it shows both the properties, such that viscous and elastic, right? So it basically exhibit the elastic recovery from the deformation. What is the meaning of elastic property? Elastic property is something like that. Due to this property, if you deform any matter, if you deform any object, it will try to regain its original shape. Like rubber is the elastic material, right? That if you stretch that rubber, that original, but after the stretching of the rubber, the state of that rubber is not the same as initial. It is basically in the deformed state. Once you remove the, you can say, stress on the rubber will try to regain its original shape. So more elastic, more chance to regain its more original state, right? So what are the materials which are perfectly elastic? Perfectly elastic are the materials which have regained its initial shape and size exactly. वो exactly अपनी initial shape and size पे आ जाते हैं. But most of the metals are not perfectly elastic. There is some deformation are there. If you apply the shear stress to any material, it will deform up to some extent after the removal of shear stress. शेयर स्ट्रेस हटाने के बाद में कुछ ना कुछ थोड़ी बहुत डिफॉर्मेशन उसके अंदर बच ही जाती है. इज इट क्लियर टू यू? So in this the viscoelastic fluid, you can say that after removal the stress, it will regain up to some extent its original state. Is it clear to you? This is the meaning of elastic. And viscous means it has the viscosity. Simple sa word hai. It has some viscosity, right? So I can write that it regain its original state with some deformation, after removal of shear stress, right? And you can write the examples like floor duff, right? And some polymers in molten state, right? So these are the some examples. So बहुत ही सिंपल सी बात है. कई कई बार इस डेफिनेशंस पे, नेम पे क्वेश्चन आ जाता है, खास करके पीएसयू के जो सेपरेट एग्जाम्स होते हैं, राइट? So we will try to cover all the things for the gate examination, for the PSU examination, and for the interview point of also. ठीक है? So we will try to cover all the things. Is it clear to you guys? Okay. So let's solve some question based upon this information. So this is I don't remember the year. This is the gate PYQ. Let me tell you the answer. या तुम लोग बताओगे? चलो, just read this problem and बताइए आप अगर आप इसको solve करना चाहते हैं. So this is very simple that you have one column in which pseudoplastic and Bingham plastic is there. And in the second column, this is the equations you have. This is the equations you have, right? Is it clear to you guys? So you have to match the column. You have to match the column. Can anybody tell me what can be the answer of it? What can be the answer? Can anybody tell me? Can anybody tell me? D. Okay. D is P3 and Q2. D. Okay, let's check the answer, guys. Let's check the answer. So basically, we have the two fluids, pseudoplastic and the dilatant. For the pseudoplastic, we have the equation. That tau is equal to any constant into the shear rate raised to power n, and this n must be less than 1. And for the dilatant, it is the greater than 1, right? Okay, for the Bingham plastic, so for the Bingham plastic, we need initially yield stress, and after that it exactly like the Newtonian fluid. So it is tau naught plus k du upon dy, right? So why you can say gamma is, you can say your shear strain rate or shear rate, right? So basically, I think P is matching with the 4 and Q is matching with the 2. Q is matching with the 2, right? Clear? So this is not, sorry, it is not 4. This is a printing mistake. This is your 3 and this is your 4, right? So P3 and Q2 is the correct option. So D is the correct option, right? Okay, good. Next. So you have a Bingham fluid of viscosity 10 pascal second, and we have the yield stress value, and it is sheared between the flat parallel plates separated by a distance of 10 raised to power minus 3 meter. The top plate is moving with the velocity of 1 meter per second. The shear stress on the plate is. So this is the scenario in this question, that these are the flat parallel plates and a Bingham fluid of viscosity 10 pascal second is flowing, or you can say is placed between these plates. You can say the lower plate is not moving, it is in the stationary, and the upper plate is moving, right? The top plate is moving with the velocity. The velocity is 1 meter per second, right? So always remember this information in this way, that the just adjacent layer which is in the contact of the plate, right? The layer which is in the contact of the plate, the velocity of that layer is basically exactly same as the velocity of that plate, right? So just remember this information like that. So the bottommost layer is basically contact with this stationary plate. So the stationary plate have the velocity 0. So this fluid layer velocity is also 0. And we know that this is the no slip condition. And the adjacent layer which have the velocity as the plate has the velocity. So what is the velocity of this plate? 1 meter per second. So the layer velocity is also 1 meter per second. Is it clear to you? Okay. Now we have to find out the shear stress. So here Bingham fluid is there. So for the Bingham fluid we have the equation tau is equal to tau naught plus mu du upon dy. So we have this yield stress. So just to calculate the velocity gradient here. So du divided by dy. What is the du? Du is basically change in the velocity, right? So this is 1 minus 0. It is 1 minus 0, right? Divided by the dy means the separation, this y length, right? So this is at y equal to 0, right? And what is this? This is the length. This separation is basically your 10 raised to power minus 3 meter. So dy is your 10 raised to power minus 3 meter. So I can say that du upon dy is equal to 10 raised to power 3 meter per second. Yeah. Okay. Now mu, we have the mu value, right? Okay. Now tau is equal to tau naught, which is 10 kilopascal, means 10,000 pascal, plus mu is 10 multiplied by the du upon dy. This is the value. Is it clear to you? So this is the 10,000, 10,000. It is the 20,000, or you can say 20 kPa. 20 kPa. So I think B is the correct option for this. B is the correct option for this. Guys, calculate हुआ सबका? Calculate हुआ सबका? Okay. If you have any doubt, you can ask by. ठीक है? There is no requirement of repeat again and again this statement, because you guys are enough mature. है ना? आप सब बीटेक पास आउट हैं. ठीक है? So I think there is no need to tell you that okay, पूछो like that. Okay guys, let's move to the second question. And the next question, this question I say that it is a very good question, I must say. This question is very good question, right? Chaliye, let's try to solve this question, guys. Let's try to solve this question. Let's try to solve this question. I hope this question is clear to you. It is visible to you or not? Just let me know, guys. एक बच्चा मुझे बता दीजिए that this is visible or not, right? And I dictate this question for you. So question is something like that. Consider a fluid confined between two horizontal parallel plates and subjected to shear flow. Okay. So question is saying something like that. That we have a parallel plates. This is the parallel plates we have. Okay, and there is a fluid which is in between these plates. Which is in between these plates. Which is in between these plates, right? Okay, so there are two experiments here. Experiment 1 is something like that. That plates are separated by a distance of 1 mm, right? So this is basically the separation. So I can say this is my dy. This is my dy, right? So in the experiment 1, dy is equal to 1 mm. And my first task is to convert these units into the SI. And it is found that shear stress, it means the tau value is given to us, that is Q Newton per meter square, which is also in the SI unit. It is good for us and has to be applied to keep the top plate moving with the velocity 2 meter per second. So and other plate is fixed. So this is a fixed plate. So the velocity of this fluid is 0 and this plate is moving with, you can say, the velocity v, right? So dv, you can say du, is basically your 2 meter per second, right? Because the lower fluid has the velocity, the bottommost fluid layer has the velocity 0. And second experiment says that now the plates are separated by the 0.25 mm, which means 0.25 multiplied by 10 raised to power minus 3 meter. And it is found that shear stress, it means the tau value, which is 3 Newton per meter square, and the top plate is moving 1 meter per second, and in this case also the other plate is fixed. So in that case your du is equal to 1 meter per second. So you have to calculate the rheological character of the fluid. You have to calculate the rheological character of the fluid, right? And here we have a word rheological. Here we have a rheological word. So let's, I will tell you the meaning of the rheological. So basically we have to find out that which is this fluid, है ना? ये fluid कौन सा है? Newtonian, ideal, inviscid, pseudoplastic or dilatant? This is the problem. This is the problem, right? बताइएगा, बताइए. So just think about this question. How we can solve this question. How we can solve this question? Just let's try to understand it. Let's try to understand it, right? Okay, let me explain this question. सोचने का मैंने मौका दिया है, आप सोच लीजिए and just try to figure out that आप same thought process से सोच रहे थे या नहीं सोच रहे थे, right? Just see that Newtonian fluid, ideal and inviscid fluid, pseudoplastic fluid and dilatant fluid. Let's take the second option, ideal. Ideal means there is no viscosity. There is no viscosity. But from the data, I can see that there is some viscosity. So it cannot be the ideal fluid. So second option to ho hi nahi sakta. It cannot be the ideal fluid. It cannot be the ideal fluid, right? What is the difference between the Newtonian and non-Newtonian fluid? The difference is only of the viscosity. है ना? This is only the difference is between the viscosity. That how viscosity is changing from layer to layer. How viscosity is changing from the layer to layer. If viscosity is same everywhere, then that fluid is Newtonian. But if the viscosity is not same, then in that case that the fluid must be the non-Newtonian. For the non-Newtonian, there may be the pseudoplastic and there may be the dilatant. So how to decide that this is the pseudoplastic or dilatant? I think we have a information that in the dilatant fluid, my apparent okay, let's take the pseudoplastic. So I have given you a graph between the apparent viscosity and the shear rate. Where I explained that this kind of graph we will get for the pseudoplastic, and this is the mu apparent and this is the shear rate, or you can say du upon dy. So for the pseudoplastic, this kind of graph we will get, and for the dilatant, this graph we will get. It means with increasing mu app, if mu app is increasing with du upon dy, then that fluid must be the dilatant, and if it decreasing, it must be the pseudoplastic. So let's calculate the mu apparent यार. एक काम करते हैं, mu apparent निकाल लेते हैं ना. Let's calculate the mu apparent and let's see that it is increasing or decreasing. Okay, so what is the mu apparent? Mu apparent is very simple. Mu apparent is tau upon du upon dy. So what is the tau value in the first case? If I talk about the first experiment, so tau is 2 divided by what is du? Du is 2 divided by what is dy? Dy is 10 raised to power minus 3. So it is 1 1000. Is it clear to you? It is 1000. I hope आपको ये कहानी समझ में आ गई होगी. ठीक है, कैलकुलेशन इज करेक्ट और नॉट? बता दीजिए इतना ठीक है. Is it clear to you guys? It is 1000. Okay, let's take the second experiment. Calculate the mu app. So here mu app, let's suppose it is mu app 1, this is mu app 2. What is the tau value? 3 divided by du is 1 and divided by what is it? Is 0.25. 0.25 multiplied by 10 raised to power minus 3. Right? Ha, minus 3. Right. Yes. It is 10 raised to power minus 3. Yeah, right. Okay. ठीक है, इतना डन है, बोलिएगा. Now let's calculate this mu app 2. What is the value? It is 3 multiplied by 0.25 multiplied by 10 raised to power minus 3, which is, I can say, 0.75 into 10 raised to power minus 3. In what is the mu app 1? It is 1 multiplied by 10 raised to power minus 3. And what is the mu app 2? 0.75 into 10 raised to power minus 3. In the first case, what is the velocity gradient, or you can say shear rate? Du upon dy is 2 upon, it is 2 into 10 raised to power 4. Right? And what is the value of du upon dy in the mu app 2? It is 1 divided by 0.25 multiplied by 10 raised to power minus 3. Right? Minus 3. So what is the value? It is 10 raised to 100 multiplied by 10 raised to power 3 divided by 25. So it is 4. So I think it is 4 multiplied by 10 raised to power 3. So what relation we will get? That from experiment 1 to 2, the shear rate is basically increasing. Here the value is 2 into 10 raised to power 3, and here the value is 4 into 10 raised to power 3. So with the increasing of du upon dy, with the increasing of shear rate, the viscosity, the apparent viscosity is decreasing. So this kind of behavior I think we will get in the pseudoplastic. Is it clear to you? Yes or no? अरे यही बताया था ना मैंने आपको, यही, this is the relation we will get, or you can say this is the relation we noted tomorrow, na? This is the shear rate and this is the mu apparent. So if it is decreasing, then it is a pseudoplastic, or if by increasing du upon dy, if it is increasing, then it is dilatant. बोलिए. Is it clear to you guys? This question is very good. So this is the question where the both the informations are useful, right? The numerical portion also and the conceptual portion also, right? Is it clear to you? So you can expect one question from the types of the fluid. Okay, you can expect one question from the types of the fluid. So just solve these questions, guys. Solve these PYQs. जहां पे भी PYQs, आप just mark the PYQ on the if you have any book, if you have the coaching book, or if you have any publication book, mark the types of the fluid question and try to solve it today itself, right? So let's take the question from the, you can take from the question 90s to the 2025. You may get from 10 to 15 questions and solve those questions, solve those PYQ. Okay, great. Okay. So guys, so these are the properties of the fluid. Till now we have studied the properties of the fluid, in which we have studied the density, specific volume, viscosity, capillarity, surface tension, all those properties. All those properties. The first part of our syllabus is, you can say that first part is our completed. First part is the completed, in which we have studied all the properties of the fluid. Is it clear to you? Right? Now let's come to the fluid mechanics, and we have there are, you can say, two part of the fluid mechanics. There are the two parts of the fluid mechanics. One is the fluid static and another is the fluid dynamics. Right? One is the fluid static and another is the fluid dynamics. Guys, ध्यान से सुनिएगा, ठीक है? Now the things are, you can say, the very conceptual now. Let's try to understand it. So till now we have completed the properties of the fluid. Now we have to deal with the separately fluid static and the fluid dynamics. This is our fluid mechanics. So first we have to know that what is the fluid static and what is the fluid dynamics. After that we will study the fluid static. पहले हम fluid static को complete करेंगे. After that हम fluid dynamics को complete करेंगे. So let's try to understand the fluid static. So fluid static. Static means stationary. Static means stationary. If fluid is at rest, then you can say that is basically comes into the category of fluid static. That's the category of fluid static. Is it clear to you? So this first case is basically your fluid static. Here this is any vessel and a liquid is filled in this vessel and there is no movement of this fluid. The fluid is at rest. Then this comes into the category of fluid static. In the second category, in the second thing, you can see here that there is a trolley here and fluid is placed on it, and this is fluid this trolley is moving, but the fluid is at rest with respect to the container. I'm not saying that with respect to the ground it is stationary. No, with respect to the container is it at rest. So fluid at rest or fluid at rest with respect to the container, both the categories lies on the fluid statics. Both the categories lies on the fluid static. Is it clear to you? I hope. Right? Now, sir, what is the fluid dynamics? Fluid dynamics means that if the fluid is moving, right? In what sense? See, if there is no relative movement between the fluid layers, जब तक fluid layers के बीच में relative movement नहीं है, that is basically comes into the category of fluid static. That is coming to the category of fluid static. In the first case also there is no movement between the fluid layers. In the second case also there is no movement between the fluid layers. But in the fluid mechanics, let's suppose the flow in the pipe, which is the fluid dynamics. So if there is a flow of the fluid with respect to container, or you can say if there is a relative motion between the fluid layers, that is basically comes into the category of what? This is that comes into the category of fluid dynamics. I hope it is clear to you guys. जल्दी बताइए. This is clear to you or not? Clear? Okay. ठीक है. Now see guys, fluid basically you can say the fluid static, or you can say, and the fluid mechanics also, we categorize the fluid mechanics, or you can say we will study the fluid mechanics from the force point of view. from the force point of view, right? So what is the meaning of force, sir? See, we have two kind of force. We will have two kind of force. One is, you can say, the body force, and another is your surface force. One is your body force and another is your surface force. You will say, sir, that what is the meaning of body force? Body force means the force which is mass dependent. This force is basically mass dependent, right? This is the mass dependent. Is it clear to you guys? And surface force is basically surface area dependent. Surface area dependent. Sir, which force comes into the category of mass dependent? The force which are mass dependent. What are those force? For the example, weight force. Weight is the force ना? अरे भाई weight क्या होता है? Force ही तो होता है, yes or no? What is the weight? Weight is the force itself. It is the mass into gravitational acceleration. So here this force is basically mass dependent. If you changing the mass, the weight force will different. Weight force will different. And another is the inertia force. Another is the inertia force. What is the inertia? Inertia force is mass into acceleration. Mass into acceleration. Is it clear to you? So these weight force and inertia force are the mass dependent force. These are the mass dependent force. Is it clear to you? What is the surface area dependent force? Example for the surface area dependent force is the pressure. Pressure force. If you changing the area, that pressure force will change. Pressure force will change. Is it clear to you? Another is your, can say, shear, right? Shear is also area dependent force. Shear is also area dependent force. Is it clear to you? Yes or no? So we will study the fluid static. We will study the fluid static. So how we study the, or you can say how we will take the steps in the fluid mechanics after today's class. So we will take the one force, studied that one force, after that we will add the another force, then we will add the another force, then we will add the another force. Like in the fluid static, there is no relative motion. There is no motion of the fluid. If there is no motion of the fluid, in that case there is no inertia force. There is no inertia force. Is it clear to you? Yes or no? If there is, see, in the fluid static, fluid is stationary. If the fluid stationary, then this ma force will not there. So in the fluid static, what is the weight? Weight is basically m into g. Yes, weight forces comes into the picture. But inertia force will not be there because their acceleration is 0. So in that case, inertia force will be absent. Inertia force will be absent. Okay. What about the shear stress? What is the shear stress? Tau is equal to mu du upon dy. Du upon dy. If there is no motion between the fluid layers, in that case mu is also absent there. Mu absent रहेगा वहां पे. मैंने क्या बताया था about the viscosity? Viscosity comes into the picture when there is relative motion between the fluid layers. But in the fluid static, there is no relative motion between the fluid layers, so there is no viscosity discussion there. So shear stress is also 0 here. Another is the pressure force. We will study the pressure force. So in the fluid static, we consider the weight force and the pressure force. These inertia force and the shear force will be absent. So these two forces basically we will study in the fluid static. As we move toward the fluid mechanics, these two forces, inertia force and shear stress force, also comes into the picture. So in the fluid mechanics, we will study all the forces: weight force, inertia force, pressure force, shear force. Is it clear to you? Sir, how is shear surface dependent? What is the shear stress, beta? What is the shear stress? एक क्वेश्चन भी करवा के बताया था मैंने. If that this is your any element, any you can say, let's suppose this is a F force which is applied on this surface A, right? So if it makes the angle to the this horizontal as theta, so there are two components of this force. This is the F cos theta and this is the F sin theta. So how you define the shear stress? We define the shear stress as this tangential force divided by area. Right, so we consider the area na in tau. Yes or no, beta? So in this context, it is the area, surface area dependent. Yeah, is it clear to you, Kia? Is it clear to you? So surface area force. Okay, let's take one example also. Let's take one example also that. Let's take example. Let's suppose somebody is let's take an example. अभी दिमाग में example आ रहा था. Let's suppose you have your laptop screen and there may be some you can say the surface area of that your laptop screen. Somebody is asking that, okay, calculate the pressure there. So you will will you calculate the any force divided by area, that is basically your force, right? And if you have any steel ball having the different mass, having the different mass but the same surface area, right? In that case, we will say that surface force are same for both the object, but because the pressure force is the shear surface force dependent force. And still the mass of your laptop screen and the steel ball is different, but still the pressure force is basically same in both the cases, right? So समझ गए आप, I think, right? कोई दिक्कत तो नहीं है to understand the body force and to understand the surface force. Body force are totally depend upon the mass dependent force, है ना? There is nothing of लेना देना of the surface area, right? मान लीजिए कि एक छोटा लड़का है मोटू सा, एक बड़ा सा लड़का है थोड़ा पतलू सा. The surface area of that two guys are different, but the mass of the two guys are same. So weight force is basically same for both the bodies, है ना? दोनों लड़कों के लिए weight same रहेगा. Is it clear to you guys? So in the fluid static, we will consider the forces weight force and pressure force. So we have the discussion of the pressure and the weight, right? Weight force and the pressure. So weight is nothing. Yeah, weight तो बहुत simple है ना? Weight is very simple. If we are talking about the weight force, if we are talking about the weight force, we know that weight, yeah. Weight is basically mass into gravitational acceleration. Gravitational acceleration, right? Weight is nothing, but it is m into g. Always take g as 9.81 meter per second square in the gate problem. Right? Never take it as 10 meter per second square. If the question is giving you the value, if question is giving you this approximate value 10 meter per second square, only then you can take this value. Otherwise consider this value. Is it clear to you? Only if this is given in the question. Yes. अरे सो गए क्या? जल्दी बोलो. हैं भाई, सो गए क्या? एवरीबॉडी सो तो नहीं गए? हाँ जी, सो गए क्या? बोलिए। हम्म। ओके। Okay, guys, so let's discuss the another force which is pressure. So हमारे पास प्रेशर का एक अच्छा खासा डिस्कशन रहेगा, ठीक है? प्रेशर का अच्छा खासा डिस्कशन रहेगा. So let's discuss about the pressure. Let's discuss about the pressure. So we have a long discussion of the pressure. We have a long discussion of the pressure, right? Okay जी. Now जब तक मैं पानी पीता हूं तब तक मुझे कोई बताएगा the definition of the pressure. What is the definition of the pressure? What is the definition of the pressure? गलत, सही, है ना? Whatever it is, आप बताइए. ठीक है, बताइए. What is the pressure? Can you tell me the definition of the pressure, guys? Force per unit area. Force per unit area. Normal force exerted per unit area. Okay. Let's suppose you have. चलिए मुझे बताइए. Let's suppose your mass is 10 kg. Hmm? Your mass is 10 kg, right? And you are standing on an area, let's suppose on a uh, for the simple calculation बोल रहा हूँ मैं, for the simple calculation बोल रहा हूँ मैं. Let's suppose you are standing, or you can say you are lie down a surface of 1 meter square, and your mass is 10 kg. Now tell me that what pressure you are exerting. What pressure you are exerting on the floor. You are basically lie down, okay, and your mass is 10 kg, and this area you are lying down is 1 meter square. Can you tell me that what is the pressure you are exerting on this floor? Anybody? 98.1 Newton. Maina beta, I am talking about the pressure, but you are giving the units of force. है ना? Newton, how can Newton be the pressure here? How can Newton be the pressure? Okay, so Newton per meter square, it is 98.1 Newton per meter square. Okay, let's see. And जिसने भी जवाब दिया है, जिसने भी जवाब दिया है after this discussion, tell me separately that you are saying correct or wrong. ठीक है, आप मुझे बताना कि सर मैं सही बोल रहा था और मैं गलत बोल रहा था, right? After this discussion. Okay, now see the definition of the pressure. What is the definition of the pressure? Just unfold this mystery. What is the definition of the pressure? Definition of the pressure is that it is rate of change of momentum transfer by fluid particles normal to the surface. So basically it is the rate of change of momentum transfer by the fluid particles normal to the surface. राइट. व्हाट इज द मोमेंटम यार, किसी को पता है क्या? व्हाट इज द मोमेंटम? मोमेंटम इज बेसिकली मास इनटू वेलोसिटी ना, mass into velocity. This is basically your momentum. This is basically your momentum. So the meaning of this definition is something like that. Let's suppose this is any surface and there is a fluid particles which is present on this surface. This one fluid particle is coming to this surface with some velocity. This fluid particle, let's suppose, having mass m1. Right, and it is coming to this surface. It is coming to the surface at particular velocity, let's suppose u1, and after striking to it, the velocity of this fluid particle is changing, and after striking, it is basically going with the velocity v1. है ना? Mass is actually same here. So there is a change in momentum here. There is change in momentum here. Is it clear to you? Likewise, all these particles striking to this surface and going upward in the upward direction, striking to the surface, going in the other direction, right? So when we can say that there is a change in momentum, if there is a change in the velocity, considering this mass is the same, if velocity is changing, we will say that momentum is changing. So fluid particles are coming towards this solid wall, or you can say any solid matter, strike to it, change the velocity, and we can say this is the moment, this is the change in velocity, or we can say that this is the change of this is the rate of change of the momentum transferred of the fluid particles on the normal to the surface. This is basically the pressure here. This is the pressure here, right? If I say that a solid object is placed on it, a block is placed on it, so these are the gas particles, or you can say fluid particle, and this is the solid object. This is the solid object. Now tell me what is the rate of momentum transfer here? What is the rate of momentum transfer here? I think it is zero. I think it is zero because there is no change in the momentum here. So understand this thing, that pressure is only defined for the fluid. It is not defined for the solid. Am I clear to you? Pressure is only defined for the fluid. Pressure is only defined for the fluid. It is not for the solid. So जो मैंने बोला कि आप लाई डाउन हो गए हैं उस सरफेस के ऊपर और उस पे आप मुझे बताइए कि कितना प्रेशर होगा. प्रेशर कैन नॉट बी कैलकुलेटेड फॉर द सॉलिड ऑब्जेक्ट बिकॉज देयर इज नो मोमेंटम ट्रांसफर देयर. It is only calculated for the fluid particles, and that is basically, we consider that rate of change of momentum transfer only normal to the surface. Only normal to the surface. Is it clear to you? So you can, if you remember, the rate of change of momentum transfer is basically the force. By Newton's second law statement यही था ना? Newton's second law statement क्या था? That rate of change of momentum is equal to force. So this is basically the rate of change of momentum, means it is force, and which force? Normal force. So the fluid particles which are exerting the force on the normal surface, है ना, normal to the surface, consider that force per unit area. That is your pressure. That is your pressure. Is it clear to you? I hope it is clear to you guys. बोलिएगा. समझ में आ गई इतनी बात? समझ में आ गई बात? So fluid particles which are exerting the force, कौन सा force? That normal force to the surface area, that to the per unit area, that is called the pressure. That is the pressure applied by the fluid. We in the solid part, in the solid, we can calculate only the weight intensity. And we can calculate the weight intensity. If you divide weight divided by area, that is your weight intensity. बोलिएगा, pressure definition is clear to you or not? Anybody? बोलिए, pressure is clear to you or not? ये तो यार बोलिए भाई। ठीक है, ओके, लेट्स मूव टू द, ठीक है, ओके, ग्रेट। नाउ अब करेक्ट, हाँ जी। नाउ सेकंड, let's define the absolute, first one, absolute zero pressure. What is the absolute zero pressure? What is the absolute zero pressure? So absolute zero pressure means that there is no fluid particles. There is no fluid particles. If there is no fluid particles, there is no momentum transfer. Or we can say that fluid particles are dead. What is the meaning of fluid particles are dead? That there is no motion of the fluid particles. If there is no motion, they cannot strike to the solid surface and the momentum cannot be changed. So that situation is called absolute zero pressure, right? So I write the definition here that if there is no fluid particle, yeah, Darshini and Hemant, गाइस आप क्लास के अंदर हैं, जस्ट लेट मी नो आप क्लास के अंदर हैं या नहीं है। इफ देयर इज नो फ्लूइड पार्टिकल्स और all fluid particles are dead, then that state is defined as absolute zero pressure, right? Guys, the students which enrolled recently, just go through the previous lectures, guys. First of all, that you can because today we are starting the fluid static part, so you can say that you can continue from this lecture also, but parallelly जो आपका you can say जो पहला वाला पार्ट है वो भी आप अपना कंप्लीट करेंगे, है ना, प्रॉपर्टीज ऑफ द फ्लूइड वाला, राइट? नहीं बेटा, pressure is not, see, pressure not depends upon the mass, it depends upon the, see, that this particle has mass m1, still the mass m1 after the striking, mass is the same, na? And in the second case also, that if you see the total mass of the fluid particles are same before striking or after striking, the fluid particles has the same, the total mass of the fluid particles is same, Roshna, after the striking or before the striking. So mass is basically not changing here, right? Here changing is the velocity, change is only in the velocity, momentum is only change due to the velocity, not due to the mass. So here mass is the fixed, clear? Okay, so absolute zero is if there is no fluid particles, or you can say that particles are dead, in that case we will say that it is the absolute zero pressure. Is it clear to you guys? Okay, now what is the absolute pressure? Second definition is absolute pressure. Absolute pressure, right? So what is the absolute pressure here? Absolute pressure is defined, something like that, that any pressure taking absolute zero as a reference, is known as, I will let you know, okay, that what is the meaning of taking absolute zero as a reference. Okay, as reference is known as absolute pressure. Is absolute pressure. Is it clear to you? So any pressure taking as absolute zero as the reference is basically your absolute pressure. What is the meaning of taking the zero as a reference? Let's see. So guys, let's suppose we are talking about the atmospheric pressure. Let's talk about the atmospheric pressure. Okay. Atmospheric pressure. What is the meaning of atmospheric pressure? Let's suppose this is our earth. Let's suppose this is our earth, and we know that earth is surrounded by the atmosphere. What is the meaning of atmosphere? That they are the earth is surrounded by the fluid. Earth is surrounded by the some fluids, or you can say the gas particles which is around the earth. There may be, I think in the geography there are 4 to 5 layers are there, and a troposphere, mesosphere, like that. So these are the, you can say, the fluid which is around the earth. So here the fluid particles are striking to the earth's surface and going, striking to the earth's surface and going, striking to the earth's surface and going. So there is a momentum transfer of this fluid particles on the earth, and due to this momentum transfer, the whatever pressure is exerted on the earth, it is called the atmospheric pressure. It is called the atmospheric pressure, right? So absolute zero means that there is no particle, or you can say that there is no particle, or you can say that particles are dead here. So if I'm interested to calculate the atmospheric pressure of the earth, so let's suppose that this is the atmospheric pressure of the earth. This is the PATM of the earth, right? Let's suppose this is the level of the atmospheric pressure of the Jupiter. This is the PATM of the Jupiter. Or let's suppose this is the PATM for the Mars. Let's try to understand it. Okay, clear? So whatever atmospheric pressure is, this is basically measured from the absolute zero, right? If somebody is saying that what is the atmospheric pressure of the earth, so from the absolute, by taking absolute zero as the reference, या reference तो लेना पड़ेगा ना, reference तो लेना पड़ेगा कि नहीं लेना पड़ेगा? Let's suppose you are, आप अपनी छत पे हैं, आप अपनी छत पे हैं. So अगर आपसे कोई पूछे कि भाई जो 4 माले हैं ऊपर, 4 बिल्डिंग है, उनकी कितनी हाइट है, तो you have to take any reference, because from the ground level it is different, from the first floor it is different, from the second floor it is different. In that way, absolute zero is our reference to calculate the atmospheric pressure. So if I take the absolute zero as the reference and I measure the atmospheric pressure of the earth, then this is my atmospheric pressure, or you can say this is my absolute pressure. This is the absolute pressure of the earth. This is the absolute pressure of the Mars. And this is the absolute pressure of the Jupiter. This is the absolute pressure of the Jupiter. So what was the definition? Definition is that absolute pressure is what? It is the any pressure taking as the absolute zero as the reference. So by the atmospheric pressure itself is the absolute pressure. Is it clear to you? Is it clear to you? So if somebody is asking that what is the atmospheric pressure? So atmospheric pressure is basically measured from the absolute zero, and this is the definition of the absolute pressure. Let me know if you have any doubt. बोलिए. हाँ जी, क्या बोल रहे थे रोशना बेटा? So it is similar to inertia. कौन से पार्ट की बात कर रहे हैं? लास्ट पार्ट की बात करें. प्रेशर डिपेंड्स अपॉन द मास मोमेंटम. हाँ ठीक है. So it is similar to the inertia. हाँ बेटा देखो, on the micro level it is something inertia, and the force which I defined there, that I consider the inertia force. In that case we will consider the inertia in terms of if fluid is in the motion. ठीक है, if fluid is in the motion, in that way. And in the fluid mechanics we have to consider the liquid only. We are considering the liquid only. ठीक है. The pressure definition I defined there is I take the example of the gas particles, because with that gas particles are easy to understand. There it is easy to understand there, right? धीरे धीरे liquid के लिए कैसे मैं pressure को बताऊंगा, you will get to know when we discuss the pressure in the liquid. But the broad definition of the pressure is it is only for the fluid, not for the solid. Inertia term is the, you can say the एक बड़ी टर्म है. इनर्शिया एक बड़ी टर्म है, उसके अंदर बहुत सारी टर्म्स आ सकती हैं. ठीक है. Is it clear to you? गैस पार्टिकल्स के अंदर हमने जो प्रेशर की डेफिनेशन समझी है वो गैस पार्टिकल्स को कंसिडर करते हुए समझी है. ठीक है. So pressure in the liquid I will let you know. Don't worry, hold on. Next topic वही है, pressure in the liquid. So this scale is clear to you or not? बताइए मुझे. बताइए. This scale is clear to you or not? बोलिएगा. Okay. So if I will talk about the atmospheric pressure on the earth, atmospheric pressure on the earth is 101,325 Pascal, and there are और भी बहुत सारी वैल्यूज हैं जैसे कि 760. अच्छा मैं आगे लिख देता हूँ बिकॉज इट इज आई थिंक नॉट विजिबल टू यू. ओके, यहाँ पे लिख दिया जाए तो आ जाएंगे क्या? चलो नेक्स्ट स्लाइड पे लिख देता हूँ. सो एटमॉस्फेरिक प्रेशर atmospheric pressure, the value of the atmospheric pressure on the earth is PATM is 101325 Pascal or 760 mm of Hg or 10.33 meter of water. Right? These are the some values of the atmospheric pressure. What are these values and how to calculate these values, how we decide that the atmospheric pressure is 760 mm of Hg, 101325 Pascal. What are these values? We will discuss this. Right? So for the calculation of the atmospheric pressure, for the calculation of the atmospheric pressure, a experiment is done. And what is that experiment? Let's understand that experiment. So now we will discuss about the atmospheric pressure, right? Okay, so what is this? See, so you can say experiment, or you can say let's take the heading calculation of the atmospheric pressure. Calculation of the atmospheric pressure. So we have a container here, and mercury is filled in this container. Mercury is filled in this container, right? All this experiment is basically performed at the mean sea level. Because why at the mean sea level? Because you can say at the mean sea level, धरती पे, अर्थ पे जो भी सी लेवल है वो हर जगह सेम है. ठीक है, सो कोई भी वेरिएशन नहीं आएगा इफ यू विल परफॉर्म दिस एक्सपेरिमेंट एट द मीन सी लेवल. Let's take a tube here which is inserted here. Right? This is the tube here, right? Okay, ji. And let's suppose I have a pump here. Let's suppose compressor here, right? And this compressor is basically what this compressor will do, that whatever air is inside this tube, it will take out of this air. Let's suppose compressor is you can say at its 10% efficiency. Let's suppose that it is the meaning of this is basically it remove the 10% of the air here. Okay, and this is basically open to atmosphere. If this is open to atmosphere, then at the top layer the pressure at this layer is the PATM, right? Okay, so if the 10% air is removed from here, then this level is basically rise up to some height. Let's suppose we now we increase the efficiency of the compressor. The compressor is basically now remove this air up to the 50% level. If this this is mercury, okay? This is mercury, right? Okay, after removing the 50% air from here, that this mercury level is basically now rising. Now at the end, this compressor removed all the air particles from here. Means there is a vacuum inside this tube, right? So let's suppose the height of the mercury is something like this, right? And this tube is closed. Okay, so basically what is this experiment there? there must not be the air particle inside this tube. उसके लिए मैंने compressor लगा के उसको समझाया, because we have to basically you can say remove the air particles, or basically we have to consider the vacuum here, right? So mercury is basically going upside at certain value it stops. And why it stops? When the pressure at this point, if it is equal to P atm, then this level will be you can say will be at the constant value. It will not increase or it will not decrease, because at this point the pressure is basically same. At this horizontal level the pressure is basically same, right? Agar pressure same nahi hoga, let's suppose if the pressure is low, so this pressure is high, so this will you can say this height will increase, right? So at a certain height, the pressure on this horizontal level is P atm, and this height recorded is 760 mm. And what is the fluid? Mercury is the fluid, so it is 760 mm of Hg. So we will say that 760 mm of Hg exert the pressure which is equal to the P atm. Am I clear to you? The atmospheric pressure is basically in the height, it is 760 mm of Hg. I hope this is clear to you. Yes or no? If I take the water in this tube, inside this tube, then we know that the mercury is 13.6 times heavier as compared to the water. So you can say the water is 13.6 times lighter as compared to the mercury. So the required level of the water will be the high as compared to the mercury to exert the same pressure. Yes or no? Right? So if you take the water here, then you will find the water height as 10.33 meter. So 10.33 meter of water and 760 mm of Hg water exert the same pressure. Is it clear to you? अरे बोलिएगा, is it clear to you? Yes or no? Is it clear to you? ठीक है. Or in it is also, you can say it is 1 atm. 1 atm is the P atmospheric pressure. Atmospheric pressure on the earth is 1 atm. So 1 atm is basically equal to 760 mm of Hg or 10.33 meter of the water. Right? Now from where this 101325 Pascal is coming? From where 101325 Pascal is coming, we will also calculate this. Don't worry, right? Is it clear to you? So this experiment is performed on the main sea level. So atmospheric pressure calculation is performed on the main sea level, and it is something that the 760 mm of Hg exerting the same pressure as the atmospheric pressure, or you can say the 10.33 meter of the water exerts the same pressure as the atmospheric pressure. It means from the, if you take the lighter fluid, height will be more. Yes, what I'm trying to say, Hg is the heavier fluid as compared to the water. If you see the difference in the height of the mercury and water, there is a big difference. 760 mm is nothing, but it is very small value as compared to the 10.33 meter. 10.33 meters is a very high value. You will need a very high tube for the water. Yes or no? So if you will take the fluid as the air, then it will basically, the height required for the air will be in the kilometers. The height required for the air will be in the kilometers. It is clear to you guys? It is clear to you or not? Yes? Okay. ठीक है. चलिए, we will discuss this 101325 Pascal in the, after defining the pressure in the liquid. Okay, now see, so what is the absolute pressure? What is the atmospheric pressure? We know that What is the absolute zero pressure? We know that. What is the absolute pressure? We know that. Now the next term is the gauge pressure. Heading डालिएगा gauge pressure. Right? यहाँ तक सबको क्लियर है? मैंने शायद आपके वो नहीं देखे, मैसेज नहीं देखे, जिस एक बार मैं गो थ्रू हो जाता हूँ. हाँ जी, ठीक है. Gauge pressure, right? So let's define this as the P gauge. What is the gauge pressure? So absolute pressure is taking the absolute zero as the reference. Likewise, gauge pressure taking the reference as the PATM. Right? So gauge pressure is basically, it will take the reference as, it will take PATM as reference. It will take PATM as reference. So gauge pressure will take the PATM as a reference, and absolute is taking the absolute zero as a reference. Right? Okay, let's understand this with the help of that diagram. So guys, we have this is the absolute zero level. This is the absolute zero level. थोड़ा सा बढ़ा, ठीक है. This is the absolute zero pressure. Okay, and let's suppose this is the mass PATM. This is the PATM for the Mars. Let's suppose, let's take this as the PATM of the Earth. PATM of the Earth, right? And this is the PATM of the Jupiter. Okay, so I think we have discussed about the absolute pressure. If you are talking about the absolute pressure, then this is the absolute pressure, because from the absolute pressure that we are taking the reference is the zero, absolute zero. This is the absolute pressure for the Earth, and this is the absolute pressure for the Jupiter. These all pressure are the absolute values, right? Now, if any, the P gauge is basically that is something which is taking the atmospheric PATM as the reference. PATM as the reference, right? If it's if somebody is saying that what is the atmospheric pressure of the Jupiter? What is the atmospheric pressure of the Jupiter? It will take the Earth atmosphere as the reference. So we will measure this pressure from here, because in this case, this is my reference level. For the absolute zero, this is my reference level, but for the gauge value, it is my reference level. So we will, if somebody is asking the what is the PATM for the Jupiter, we will say that it is basically, this is now, you can say the P gauge, that how much pressure is above the atmospheric pressure of the Earth, right? If let's take that what is the atmospheric pressure, or you can say what is absolute atmospheric pressure of the Mars, right? In the gauge term, how I will define, this is my reference level, so measure from here, that this is my atmospheric, measure from, this is, you can say, the negative gauge. Is it clear to you? Let's just for the Jupiter atmospheric pressure. So this is, if we calculate from the absolute zero pressure, then absolute so Jupiter atmospheric pressure है ना, is basically, this is in the absolute term ना भाई, this is the absolute term. So चलिए, I can say that this is absolute term, which is equal to this pressure is equal to द यहां से लेके यहां तक, फ्रॉम हियर, फ्रॉम हियर इट इज P ATM of the earth, P ATM of the earth प्लस यहां से फिर यहां, what is it? It is a P gauge. It is the P gauge. Is it clear to you? Okay, there's no need to write all these things. ठीक है, मैं एक बार समझा रहा हूँ, and after that I will write the final equation. If somebody is asking that what is the absolute pressure for the Mars, what is the absolute atmospheric pressure for the Mars? So we will say that the what is the reference level? P ATM now, P ATM of the earth. So P ATM of the earth, and so from the to reach uh, to reach up to the mass level we have to go downward direction, so we have to minus P gauge. Minus P gauge is also called vacuum. Minus P gauge is also called vacuum, right? Clear? So this is my absolute pressures, and how we calculate this absolute pressure. In the P ATM we are adding or subtracting the gauge pressure. So this is my final equation, P ATM plus minus P gauge. This is the important equation. Okay guys, let me know that this is clear to you or not. This is clear to you or not? This is clear to you or not? So gauge pressure, in the gauge pressure, P ATM is our reference. P ATM of the earth is our reference, and in the to calculating the absolute level, absolute zero pressure is our reference. Just remember this equation, that if somebody is asking about the absolute pressure, so we have to add the P ATM, है ना? So you have to add the P ATM plus minus the gauge pressure, and this gauge pressure is the vacuum pressure, right? Okay, this is my another term is that absolute vacuum. Another term is that absolute vacuum, right? So what is the absolute vacuum? Absolute vacuum is basically this pressure. This pressure. If you are coming from P ATM earth to the absolute zero pressure, that is called absolute pressure. So if the question is absolute zero pressure is the absolute vacuum pressure. Question is absolute pressure is same as that the absolute vacuum pressure? We will say no. We will say no, right? Absolute zero pressure is not equal to the absolute vacuum pressure, because absolute vacuum pressure can be different for different planets. It is different for the different planets, right? So like let's suppose that this is my, let's take only two example. This is the P ATM for the Jupiter, and this is the P ATM for the Earth, and this is the absolute zero. This is the absolute zero. Absolute zero pressure is same for every planet. Absolute zero pressure is same for every planet, but absolute vacuum is different for different planets. Let's suppose my P ATM is my 1 ATM, and P ATM of the Jupiter is, let's suppose, is 100 ATM. So what is the absolute vacuum? Means negative gauge, na? Vacuum means negative gauge, na? So negative gauge means you have to go downward up to the absolute zero. So if I'm calculating for the Jupiter, so I have to go from the Jupiter atmospheric pressure. So this is my Jupiter atmospheric pressure. I have to go downward. So what after minus 100 ATM, I'm at the absolute zero level. So absolute vacuum pressure for the Jupiter is minus 100 atm, and for the your it is for the Earth it is minus 1 atm. Absolute vacuum means there is no particles there. Nothing. Absolute means nothing. Absolute means nothing. So if something is around the atmospheric pressure, if something is around the Earth which is exert the 1 atm pressure, if take out that 1 atm, if I take out all the particles from there which is exerting the 1 atm, है ना, after taking out all the fluid particles, I will reach up to the absolute zero. So for that purpose I have to decrease the pressure up to 1 atm. जो फ्लूइड पार्टिकल जितना प्रेशर लगा रहा था वो पूरा का पूरा अगर मैं हटा दूंगा तो वैक्यूम जनरेट हो जाएगा. वैक्यूम जनरेट हो जाएगा. यस और नो? राइट. एंड इन द सिमिलर वे फॉर द जुपिटर द एटमॉस्फेरिक प्रेशर इज डिफरेंट. इट इज 100 atm क्योंकि वहां का एनवायरमेंट अलग है. ठीक है. सो जब मैं उस एनवायरमेंट को हटाऊंगा सो आई हैव टू रिमूव द 100 atm प्रेशर to reach up to the absolute zero, because at the absolute zero there is no particles. There is no particles. Is it clear to you? So absolute zero is same for every planet, but absolute vacuum is different for different planet because the atmospheric pressure is different for यार, है ना. एब्सोल्यूट एटमॉस्फेरिक प्रेशर सब प्लेनेट के लिए अलग है, तो उसके लिए वैक्यूम जनरेट करने के लिए भी तो प्रेशर डिफरेंट होगा ना. नो. बोलो. नहीं, ऐसा नहीं है. बताइए. नहीं है क्या ऐसा? नहीं नहीं नीरज, दिस इज विद द योर डेफिनेशन. बेसिकली हमें एब्सोल्यूट जीरो से ऊपर जाना पड़ेगा. If you are going upward from the absolute zero, it will basically your gauge, not the vacuum. You have to come downward from the atmospheric pressure up to the zero. ठीक है. Absolute vacuum means nothing is there. Absolute vacuum means nothing is there. Nothing is there. Means you have to achieve the absolute zero condition. For that purpose, what you have to do, you have to remove all the fluid particles, or you can say how, for that purpose, how much pressure you have to remove. ऐसे ऐसे करके देख लो. हाँ बिल्कुल नेगेटिव साइन के साथ आप बोल सकते हो, बट क्यों नेगेटिव? आप ऐसे याद रखो ना जैसे मैं बोल रहा हूँ यार, है ना. मैं जैसे बोल रहा हूँ आप ऐसे याद रखो ना. That for the vacuum you have to go downward. If like अर्थ का एटमॉस्फेरिक प्रेशर कितना है? 1 atm. 1 atm. सो एब्सोल्यूट जीरो करने के लिए कितना atm आपको नीचे आना पड़ेगा? -1 atm, है ना. फॉर इसी तभी क्या होगा? एब्सोल्यूट वैक्यूम जनरेट होगा वहां. अगर आपने 0.5 atm पे आए, लेट्स सपोज यू आर एट द बाय डिक्रीजिंग 1 you are at the 0.5 atm, let's suppose, but at the 0.5 atm there are some fluid particles are there at. इसका मतलब यही तो हुआ. So -1 atm पे सारे के सारे पार्टिकल्स गायब होंगे, है ना. दिस इज हाउ यू कैन अंडरस्टैंड इट. एट -1 atm सारे के सारे पार्टिकल्स गायब होंगे, है ना. एंड फॉर द जुपिटर एट द -100 atm सारे के सारे पार्टिकल्स गायब होंगे, because there is a different environment around the different planets. That's why there are different planets ना यार, है ना. अगर सेम इन्वायरमेंट हो जाए जुपिटर पे भी या हर प्लेनेट पे, तो हम वहां भी प्लॉट ले लेंगे. अर्थ वाले जो इंसान हैं वो आपको पता ही है ना कितने खतरनाक है ना. पता है ना आपको कहाँ कितने खतरनाक है. आपने न्यूज सुना होगा कि चांद पे प्लॉट ले लिया, ये हो गया वो हो गया, है कि नहीं. सो अगर सेम इन्वायरमेंट हो, इफ planets exerting the same atmospheric pressure there also, then there may be a chance of living conditions there also, है ना. पर ना ही हो तो अच्छा है. अर्थ को हमने कितनी अच्छी अर्थ थी, हमने इसको कितना बेकार बना दिया है फॉर द सेक ऑफ डेवलपमेंट, है ना. एंड आप देख ही रहे हैं उसका नतीजा, ऑल दीज फ्लड्स एंड ऑल दैट, लैंड स्लाइडिंग. ये हमारी ही तो देन है. यस और नो? ये हम ये कोई ऐसा थोड़ी है कि ऐसा भगवान क्यों कर रहे हैं, नहीं. ये तो हमने नेचर को करने पे मजबूर किया है. Yes guys, so just let me know that it's clear to you or not. It's clear to you or not, बताइए. दो मिनट. एब्सोल्यूट विच वन इज ग्रेटर, एब्सोल्यूट जीरो एंड एब्सोल्यूट प्रेशर? बेटा एब्सोल्यूट जीरो मींस देयर इज नो प्रेशर. एब्सोल्यूट जीरो तो कुछ है ही नहीं. सियान, एब्सोल्यूट जीरो इज नथिंग. Absolute zero is nothing. Absolute pressure is some value. Absolute, in the absolute pressure, you have to add some gauge pressure in the atmospheric pressure. After that, you will calculate that absolute pressure. Absolute zero is nothing. Absolute zero means no state. There is no pressure. जीरो मार्क करना है आपको, कहीं पे जीरो मार्क करना है. जीरो मीन्स नथिंग. ठीक है ना, जीरो मार्क करना है, कुछ है ही नहीं वहां पे. राइट. कौन सा बड़ा है कौन सा छोटा है, दिस इज ऑल बेसिकली हैव द डिफरेंट डिफरेंट रेफरेंसेस. ठीक है. मान लीजिए कि आप ये कहें कि मान लीजिए कि 3 फ्लोर है. एक ग्राउंड फ्लोर पे खड़ा है बच्चा, एक फर्स्ट फ्लोर पे खड़ा है, एक सेकंड फ्लोर पे खड़ा है. ठीक है. एक ग्राउंड फ्लोर पे है, एक फर्स्ट फ्लोर पे, एक सेकंड फ्लोर पे. फर्स्ट फ्लोर वाला कहता है कि मैं नीचे हूं, बट ग्राउंड फ्लोर वाला कह रहा है कि नहीं नहीं यार आप तो ऊपर हो. सो फर्स्ट फ्लोर इज बेसिकली जो नीचे है वो है किसके रेफरेंस में, ऊपर वाले के रेफरेंस में. बट इफ यू आर टेकिंग रेफरेंस फ्रॉम द बिलो फॉर द ग्राउंड लेवल बॉय, तो आप उससे ऊपर हैं. ठीक है. हम्म. Absolute vacuum, what it means, sir? Can you explain? Absolute vacuum means that you are removed everything. आपने सब कुछ वहां से आपने वहां से एब्सोल्यूट वैक्यूम का मतलब क्या है? सिंपली द मीनिंग ऑफ एब्सोल्यूट वैक्यूम इज कि यू हैव रिमूव्ड ऑल द पार्टिकल्स देयर. ऑल द पार्टिकल्स देयर, सारे के सारे पार्टिकल आपने सक आउट करके, सक्शन करके बाहर निकाल. नाउ व्हाट इज द वैल्यू ऑफ एब्सोल्यूट वैक्यूम इन टर्म्स ऑफ प्रेशर? सो आपने कितना प्रेशर लगाया, एटमॉस्फेरिक प्रेशर से आपने कितना नीचे कितना प्रेशर लगाया ये स्टेट अचीव करने के लिए. एब्सोल्यूट जीरो तक पहुंचने के लिए आपने कितना प्रेशर लगाया, दैट इज द वैल्यू ऑफ एब्सोल्यूट वैक्यूम. है ना. कब एब्सोल्यूट वैक्यूम अचीव हो जाएगा? जब सारे के सारे पार्टिकल वहां से बाहर हो जाएंगे. सियान, इट इज क्लियर टू यू नाउ? कब एब्सोल्यूट वैक्यूम अचीव हो जाएगा? जब सारे के सारे पार्टिकल्स यू डिग आउट फ्रॉम दैट प्लेस एंड वो कितना प्रेशर आपने लगाया बिलो द एटमॉस्फेरिक प्रेशर, दैट इज बेसिकली योर absolute vacuum pressure. Because absolute vacuum pressure is basically calculated from the reference. What is the reference for that? Atmospheric is the reference for that. Okay, so great guys. So this is it from my side for the today's class. Okay, and in the next class we will discuss the Pascal's law, hydrostatic law is that, which is the laws which is associated for the with the pressure, है ना. And we will basically in the fluid mechanics we deal with the liquid behaviors only. So whatever the laws are associated with the pressure we will study in the next class. Okay, so till now thank you so much and we'll see you in the next class. Bye bye, take care. I hope आपको अच्छे से क्लास समझ में आ गई होगी. And also the further we will study these laws with the help of animation also. So कुछ मैंने आपके लिए अरेंज की हैं चीजें टू मेक यू अंडरस्टैंड बेटर, है ना, ताकि आपको फ्लूइड बहुत अच्छे से समझ में भी आए और आप अच्छे से इसके क्वेश्चंस भी सोल्व कर पाए. ठीक है, चलिए, थैंक यू सो मच, बाय बाय, टेक केयर गाइस.